Welcome to the second part of our logical functions guide. In this section, we'll dive deeper into more advanced functions that help you make decisions and control logic in Engini. Whether you're comparing values or evaluating conditions, these functions will provide the flexibility and control you need for more dynamic workflows. Let's continue exploring how they work. Let's start with the LESS function. This function compares two values to determine if the first value is less than the second. It returns true if the first value is less and false otherwise. For example, if we use less with the values 12 and 9, the function will check if 12 is less than 9. Since it's not, the output will be false. Let's test this by comparing two values. After saving and testing, the result is exactly as expected. Now, let's take a look at the LESSOREQUAL function. This function compares two values to determine whether the first value is less than or equal to the second. It returns true if the first value meets the condition and false otherwise. For example, if we use less or equal with the values 12 and 12, the function will check if 12 is less than or equal to 12. Since it is, the output will be true. Let's test this by comparing two values. After saving and testing, the result is exactly as expected. Let's move on to the switch function. This function evaluates a given expression against a list of possible values and returns the result corresponding to the first match. If no match is found, an optional default value can be returned. In this example, we will initialize a new activity, such as get records, and use the switch function to check whether the account number equals 61. If it does, the function will return great. If it doesn't, the function will return not great. Now, let's test this by running the switch function. The result is great because the account number is indeed equal to 61. Next, let's explore the ISNULL function. This function checks if an expression is null and returns true if it is, and false otherwise. Additionally, if an alternate result is provided, the function will return that value if the expression is null, or the expression's own value if it's not. For example, using ISNULL with the dynamic content of account number and the alternate result, 123, will return 123 if the account number is null. Otherwise, it will return the actual value of the account number. Let's test this by running the function. After saving and executing, the result is the account number because it isn't null. Let's move on to the NULL function. This function simply returns a null value, which can be useful when you need to explicitly define a value as null within your workflows or logic. Let's test this by returning a null value. After saving and testing, the result is exactly as expected. Let's move on to the IN function. This function checks whether the first argument is contained within an array of values provided as the second argument. It returns true if the value is found and false if it isn't. For example, using IN with the value John and an array that contains the elements John, Engini, and Yuval will check if John exists in the array. If it does, the function will return true. Otherwise, it will return false. Let's test this by running the function. After saving and executing, the result is true since John is indeed in the array. Let's finish with the try-parse function. This function attempts to parse an expression and returns the calculated result if successful. If the parsing fails, it returns the supplied default value. For example, if we use try-parse with the string 100 and a default value of null, the function will attempt to parse 100 as an integer. If successful, it returns 100. Otherwise, it returns null. Let's test this. After saving and testing, the result is 100 exactly as expected. That wraps up our logical functions guide. Be sure to continue exploring these functions to enhance your automation processes. Thanks for following along, and I look forward to seeing you in the next guide.